Okay, going to be working problems out of 2-4, and this section is called exact equations. What we're going to be doing, we're going to be taking a look at the differential equation. Hopefully it'll look like something of this form, and then we'll be checking that the partial derivative of m with respect to y, whether or not it's equal to the partial derivative of n with respect to x. If we have that, then it's an exact differential equation, and we can proceed with a method. So let's take a look at number 1. And I think I'll just start right here. So number 1, we have 2x minus 1 dx, and then plus 3y plus 7 dy equals 0. So let's first see that we do have the form that we're looking at here. And so this is our m function, and this is the n function. And so let's check the partials. The partial of m with respect to y is equal to 0, since m doesn't have any y's in it. So we treat the x like a constant. And then the partial of n with respect to x is also 0, since n does not have any x's in it. So we're treating y like a constant. So yes, indeed, this is an exact differential equation. Now, the question is, what do we do next? Well, what we can do is we can just remember that what we're trying to determine is that this up here is the total derivative of some function, z, which is some function of x and y. And so its total derivative would be the partial of f dx plus partial of f with respect to x dx plus partial of f with respect to y dy. So we need to come up with this function f, right? Okay, so to do this, we're going to do something called partial integration. So what we can see is we need this right here to be the partial of some function f with respect to x, and this to be some partial of some function f with respect to y. Our goal is to figure out, again, what is that f equal to. So we can begin by putting down that the partial of f with respect to x is 2x minus 1. And then what we could do is integrate. So if we integrate and integrate, then we are integrating with respect to x here. So I should probably squeeze that in there. Integrate that with respect to x. Integrate this with respect to x. And the left side should just be our function f. And the right side is just antiderivative here, which would be x squared minus x. Now normally we put some constant, but it is possible that what we get here has y's in it, and y's or constants, and so that when we took the derivative of this thing with respect to x, this whole thing here would have gone to 0, and see, it doesn't appear in here. So that antiderivative at this point, we always have to account for this right here, the possibility that it could contain y's in it. So we know right now that little f is at a minimum x squared minus x plus something that possibly has y's in it. All right, so now what we do is we differentiate that with respect to y. And what we get is, well, that's 0, minus that's 0, and then plus, now the derivative of this with respect to y is just g prime of y. But we need that, whatever that turns out to be, that entire line, to be equal to this. So since these are zeros, we can ignore them, which means that g prime of y, g prime of y must equal 3y plus 7. Now, same thing, we can integrate here with respect to y, because remember, we were trying to figure out, we knew what f was, the only thing we didn't know was this, what was g. So we are going to find g by taking the antiderivative of g prime with respect to y. And then on this side, the antiderivative of 3y plus 7 with respect to y. So what we get on the left is g of y, And on the right side, we get 3 halves y squared plus 7y plus some constant possibly. And it can only be a constant because remember we set up here, this g of y right here, could only have y's in it or possibly constants. So it is possible here that we can get a constant in here. We already have some y's in it, but it's possible to get a constant. So we can put plus c. All right, now we are ready to write down our function f. So f, little f, is equal to x squared minus x plus, now here's g, so g is down here, so plus 3y squared, or 3 halves y squared plus 7y, and then plus some constant. So now, since this, what we had up here, remember we were saying that this entire thing up here was some function f, and that it was equal to 0, right? Here, sorry, that this up here was the derivative of some function f, the total derivative. Then if it's equal to 0, then if we integrate it up, that means f would be some constant. So we know what f is. Here's f. And so the solution is this equation, x squared minus x plus 3 halves y squared plus 7y plus some constant must equal some constant, some other constant. And then you could just subtract c from both sides. So really from here on out, when we get to this step, if we ever have a plus c, I'm just going to say that it's 0 because we're always going to get a constant on the other side. So we can just get rid of this and just say, yeah, this is some constant. All right, this is it right here. All right, so that equation represents the solution to this differential equation. Which just means, right, if you took 2x minus 1, you figured out what dx was, so derivative of this with respect to x, plugged it in here, and then this, derivative of this with respect to y, plug it in here, you should get 0. All right, let's look at number 2. So 2, oh, I lost my page. 5x plus 4y dx plus 4x minus 8y cubed dy equals 0. All right, so now let's check what's the partial of m with respect to y. So looking at this is m. Partial of that with respect to y is just 4. And then the partial of n with respect to x, that one there is just 4. So yes, it is an exact equation. So I'm going to start off with looking at the partial of f with respect to x. It needs to be that piece right there. Now I integrate this with respect to x. So that means we're treating y like a constant. So the left side's f, the right hand side is 5 halves x squared plus 4y is a constant, so the antiderivative of a constant is the constant times x. So I'm going to put 4xy. And then plus, we could possibly have some function of y, just like we had in the last problem. Now we differentiate this with respect to y, and we get 0 here, but notice this time when we differentiate that with respect to y, we're treating y like the variable, so 4x is a constant. The derivative of y is 1, so you just get 4x here, and then plus the derivative of g with respect to y. Now, we need that this entire thing be equal to this right here. So we set them equal to each other. So 4x plus g prime y must equal 4x minus 8y prime, or sorry, 8y cubed. Now the 4x's cancel on both sides, and we get g prime of y must then be negative 8y cubed. And if we integrate both sides here with respect to y, then we get g of y equals negative, what is that, 2y to the fourth plus some constant. But remember I said I don't care about that, so I'm just going to ignore it. And so you can see that my function that I'm looking for, f, is equal to this plus g of y, which is this. So that's going to go right in here. And that's going to be my function, or my function, 5 halves x squared plus 4xy plus g of y, which is actually minus 2y to the fourth, and that will be equal to some constant. All right, so there we go. Oh, you know what? I just realized that was number 3. Oops. That was number 3. I made a mistake. Let me move on to the next one, which I'll do number 2. So number 2 is actually 2x plus y dx minus x plus 6y dy equals 0. So let's just check real quick. I'm going to write it this way. Partial of m with respect to y, that's another notation, which is this one. That derivative is 1. Then the partial of n with respect to x, which is the derivative of this one with respect to x, is actually negative 1. Be very careful here. This right here was a minus, so it should be a plus. It should be distributed through. It's a minus here and a minus here. So when you take derivative of that, you're going to get negative 1. And these are not the same, and therefore it is not an exact equation. And the instructions say that we're supposed to figure out if it's exact or not, and if it is exact, to solve it. If it's not, we're just going to say it's not. So, okay, number 4. I already wrote it down here. We have m here, and we have n here. And we're going to take the partial of m with respect to y, which is, let's see, derivative sine y is cosine y. And then we're treating y like a variable. This is all a constant right here, so derivative of y is just going to be 1, but we still have the constant, so minus sine x is still there. So that is our partial with respect to partial of m with respect to y. Now the partial of m with respect to x is going to be, well, let's see, derivative of this is negative sine x. And then, let's see, this is x as our variable, so we treat that like a constant. Derivative of x is 1, so we just get cosine y. And notice that those are the same, therefore we can proceed. Now, this is equal to our partial of f with respect to x. So we know it's sine y minus y sine x. And now we integrate with respect to x, integrate with respect to x, and left side becomes f, and the right side becomes, let's see, sine y is a constant, so it's just going to be x sine y, because the antiderivative of constant is the constant times x. And then here, again, this is a constant, so negative y comes for the ride. And then antiderivative of sine is negative cosine. So I'm going to change this to a plus here. Then plus some function of y, that's what we need to go find now. So we take the derivative of f with respect to y. So now y is the variable, so that means x comes for the ride. Derivative of sine of y is cosine y. And then plus, we're differentiating with respect to y, so derivative of y is 1, but cosine x comes for the ride. And then plus g prime of y. And now that must match this up here. So we set them equal to one another. We have x cosine y plus cosine x plus g prime y must equal cosine x plus cosine y minus y. So x cosine y cancels and cosine x cancels, and all you get is g prime of y equals negative y, which means when we take the antiderivative with respect to y, we get g of y equals negative 1/2 y squared, and then plus a constant, but we again don't care about that. So our answer is going to be this function here, and we'll replace g of y with this. So we'll get x sine y plus y cosine x, and then minus 1/2 y squared equals some constant. All right, and that is number 4. Let's move on to number 5. See if I have enough room. I should. So for number 5, all right, 2y squared x minus 3, 2y squared x minus 3 dx plus, so I don't have to distribute, 2yx squared, 2yx squared plus 4 dy equals 0. So partial of m with respect to x. So derivative of this thing with respect to x, the derivative of that's just 1, and then we still have the 2y squared there. Partial with respect to y. Almost did it. Partial with respect to y, not x. This time x is the constant, so derivative of y squared is 2y, but we already have a 2 out there, so this is 4yx. Okay, partial of n with respect to x is derivative of this one, so the 2 pops out and we get 4yx, and those are the same thing. So now we proceed. We know that the partial of f with respect to x is 2y squared x minus 3. We integrate that. I'm not going to write the integral sign. The integral, the antiderivative will give us f, and then we take the antiderivative of this with respect to x. The only thing that happens is that this right here becomes 1/2 x squared, so we get the 1/2 and the 2 kind of cancel out, and then the antiderivative of negative 3 is negative 3x, then plus some function of y. Now we take the derivative of that with respect to y, and we get 2yx squared minus 0 plus g prime y. That must match up with this. So if I take that, 2yx squared plus g prime y, that must equal 2yx squared plus 4. These cancel, and you just get that g prime of y equals 4, which means that g of y, taking the antiderivative with respect to y, is just 4y. So our final answer is y squared x squared minus 3x plus g of y, so plus 4y, and that equals some constant. All right. Okay, number 6. (2y minus 1 over x plus cosine 3x dx, dy dx. Ooh, okay, changing it up here now. dy dx plus y over x squared minus 4x cubed plus 3y sine of 3x equals 0. All right, that looks like a pretty good mess. So let's multiply everything, all the terms. So that means multiply this term this term, this term, this term, and the 0 on the other side. Let's multiply everything by dx, which would get rid of this here. That would now become just dy. But all these terms would get a dx next to them. So let me do this. How about we just put these in parentheses, put dx next to them. And now we have what we need. This is m, be careful because we have to be in front of dx. We have addition between these. This is n because it's in front of the dy. All right, so now, here we go. The partial of m with respect to y is, so here, this is really like y times 1 over x squared. The x is a constant, so derivative of that's just 1 over x squared. Minus, let's see, derivative of 4x cubed is 0. And then over here, this is a constant, so we just need to take derivative of y, which is 1. So we should have plus 3 sine 3x. All right, so we can get rid of the 0 there. All right, now what is the partial of m with respect to, n with respect to x? So now we're taking a look at this one. And let's see, derivative of 2y is 0. This right here is the same as negative x to the negative 1. So when you take derivative of that, you get the negative 1 pops out, so you should just get positive 1 x to the negative 2, which is still 1 over x squared. And then the derivative of this is going to be, was that a plus? Hold on. Plus. Minus, yeah, that looks like we are not going to have exactness here. The derivative of that is negative sine of 3x times 3, because we have to use chain rule there. And you can see this matches, but these do not match. They are off by a sign. This one's negative, that one's positive. Therefore, these are not this is not an exact equation, and we move on. 7. Okay, x plus y times x minus y. That's a difference of squares factored. Dx plus, good, we see a plus sign, x times the quantity x minus 2y dy equals 0. Let me just double check that. Make sure I wrote it down right. Okay, this is all good. I think what I'm going to do, because I don't want to take the derivative of a product, I could do product rule there and there, but I'm going to put those together. So this is really x squared minus y squared dx plus x squared minus 2xy dy equals 0. And now we've got our m here and we've got our n there. So the partial of m with respect to y is negative 2y, and the partial of n with respect to x is, let's see, 2x minus 2y. So, same situation. These are not the same, and therefore it is not exact. Hey, that's not, I guess, nice. We get to move on. Great. 1 plus natural log x plus y over x dx plus, oh no, equals, sorry, equals 1 minus natural log x dy. All right, so the first thing I'm going to do is move everything to one side so that it looks like the form that we're looking for. And when I move that stuff on the left side, it's going to become 1 minus natural log x dy equals 0. Now, I need a plus in the middle, so I'm going to distribute that negative through. So that's plus, so both of these become negative, or you get a negative applied, so that becomes minus and that becomes plus. And now you have your m here and you have your n there, and we can check. Partial of m with respect to y. This is the only term that has y in it. So that's really y times 1 over x, and x is a constant, so the derivative of that is just 1 over x. Whoa! And then partial of n with respect to x is just derivative of that right there, and that's just 1 over x. Ah, we finally have one, so it's an exact. So now we know that the partial of f with respect to x must be this first one. So that's, let's see, well, I'll just write it down separated. 1 plus natural log x plus, I'm going to write that as y times 1 over x. Okay, so that's what partial of f with respect to x needs to be. Now we integrate both sides with respect to x. We get x plus, now the antiderivative of natural log of x. Oh, hold on. Okay, sorry, I had to take a call. I forgot where I was. What was I doing? Taking the derivative of the, no, integrating this with respect to x. Okay, the antiderivative of natural log of x, there's a formula for that. Natural log of x, x natural log x minus x is the antiderivative. And then here, since y is a constant, we just get plus y natural log x. And then we have plus some function of g, possibly. Now we take derivative of that with respect to y, and let's see, a lot of this stuff goes away. The only thing we have left comes from here. That's just going to give you natural log x, and the plus the derivative of g with respect to y. All right, so now we need that to match up with the n from above, so this must equal, up there we have -1 plus natural log x. I don't need the parentheses. So you can see that the natural logs cancel, so g prime of y equals -1, which means when we take the antiderivative we just get -y. So our function, our answer, is going to be this, and then plus -y, so I'm going to cheat here. It's going to be just minus y, and then we need that to be equal to some constant. Let me erase the f out here. So this is the equation. That equation satisfies this differential equation up here. All right, so here's number 9. I've written it down, and we've got what m and what n are. So the partial of m with respect to y is equal to 3y squared minus 2y sine x. I'm going to move a little faster through these partials. And then the derivative of n with respect to x is 3y squared minus, well, we're going to have to take derivative of cosine x, which is negative sine x. So that's where this negative is going to come from. So minus 2y sine x. And so yes, they check out. It is an exact equation. And now we go through the process. So partial of f with respect to x is equal to m. So that's y cubed minus y squared sine x minus x. We integrate this with respect to x, and we get xy cubed minus xy squared. Oh no, oops. Okay, antiderivative here, we have to take antiderivative of sine x, which is negative cosine x, so plus y squared cosine x, and then minus 1/2 x squared, and then plus possibly some function of y. All right, so that is our antiderivative with respect to x. Then we take derivative of that with respect to y. We get 3xy squared plus 2y cosine x, and then derivative of negative 1/2 x squared is 0, and then we have plus g prime of y. And then when we set that equal to the n function, we see that they match up exactly. So everything's going to cancel. And that means that g prime of y is 0. And what that tells us is that g of y is just some constant. But remember, if we get a constant at this step, we're just going to treat it as 0. So that means that the answer is going to be the original function right here, with this g of y being nothing. And we want to say that that equals some constant, and I'll erase that f out there. So that's what we've got right here. That should be our relationship between x and y that would satisfy that differential equation. All right, moving on to number 10. X cubed plus y cubed dx plus 3xy squared dy equals 0. So here's our m, here's our n, and the partial of m with respect to y is 3y squared. Partial of n with respect to x is 3y squared. Yes, checks out. So partial of f with respect to x has to be x cubed plus y cubed. When we integrate that with respect to x, we get 1/4 x to the 4th plus xy cubed plus possibly some function of y. Differentiate that with respect to y, and we get 3xy squared plus g prime of y. And when we set that equal to this, we're going to again get 0. So I'm going to kind of skip that step because they'll cancel out. The 3xy squareds will cancel out. All you get is that, and that means that g of y is some constant, which we will ignore. So our answer should just be 1/4 x to the 4th plus xy cubed equals a constant. And that came from right here, with g of y being 0. All right, so that's number 10. Let's look at 11. 11. Okay, y natural log y minus e to the negative xy dx plus 1 over y plus x natural log y dy equals 0. So m and n, and we check. Partial of m with respect to y is, well, we've got a product rule right there, so that's going to be natural log y plus derivative natural log of y is 1 over y, but then times y, you just get 1. And then minus, the derivative of e to anything is itself, but then you have to take derivative of what's up here with respect to y. So we're treating x like a constant, so derivative of y is 1, so we just get negative x there. And yeah, I'll just leave it like that. Now, partial of n with respect to x should be, let's see, the only thing we have here is just, that's that right there. So natural log of y. That's all we get for, which one are we on? 11? So, did I write this down? And with respect to x, I'm just checking something here. Okay, something in the book, I thought it said it was exact. I was like, it's not exact. What the heck's going on? Okay, yeah, so it's not exact. We're done. All right, 12. Sorry about that. Number 12. 2x over y dx minus x squared over y squared dy equals 0. So there's m, and there is, oh, careful here. Make this a plus, let's put this minus up here. So that is your n. And this is your m. So remember, m is actually, if we want to look at it a different way, it's 2x times 1 over y. And then n, we rewrite that, that's negative x squared times y to the negative 2. So that's that 1 over y squared, we're just going to bring it up. That might just make our derivatives a little easier. So partial of m with respect to y. This 1 over y, I guess I could have written that as y to the negative 1. Yeah. Now when we take derivative of that with respect to y, the negative pops out, negative 2x, y to the negative 2. And then we take the derivative of n with respect to x, we get power rule just on this. So 2 pops out, so negative 2x, and then we already had y to the negative 2 there, so it checks out. They're exactly the same. So that means that partial of f with respect to x has to be 2x y to the negative 1, which I'm using this version up here. And then antiderivative of that with respect to x would just be x squared y to the negative 1 plus some possible function of y. And derivative of that with respect to y is negative x squared y to the negative 2. So I was just using power rule on y to the negative 1 plus g prime of y. And you'll notice that this matches up here exactly. They mean exactly the same thing, which means that this is 0. And whenever that's 0, we get a nice, easy answer. So we just take this, I'll rewrite it as x squared over y. That's the first part. And then that must be equal to some constant. All right, and that is number 12. Now the book does this, but that doesn't really matter. Okay, multiply both sides by y. $13. X dy dx equals 2x e to the x minus y plus 6x squared. Double check I got it written down right. X dy dx equals 2x e to the x minus y. Okay, so let's multiply both sides by dx. That'll clear it on this side. You'll just have dy here. And then over here, you're going to have dx multiplied. So now let's move everything to one side. So I'm going to take everything to the right. So 2x e to the x minus y plus 6x squared dx, that's my m, and then minus x dy, and remember I need this to be a plus, so make sure you look at this as being plus, and then this is negative x in front, equals 0. All right, now our partial of m with respect to y would be negative 1, that's very nice, and then partial of m with respect to x would also be negative 1, so it is an exact equation. So we can continue. We know that the partial of f with respect to x is equal to 2x e to the x minus y plus 6x squared. So now we integrate that with respect to x. And let's see, a couple of these terms are pretty easy. Minus yx here, and then this one is plus 2x cubed, and then we have plus some function of y. But we have to integrate 2x e to the x. And so the integration on this is going to require, I'll take the 2 out, it'll require integration by parts. So I'll just do a quick by parts here. And so this becomes 2, and then x e to the x minus integral e to the x dx. And this is going to be 2x e to the x minus 2e to the x. All right, so that all goes here. Let me make myself some room. So 2x e to the x minus 2e to the x. That's a heck of a antiderivative. Okay, so now now that we've got this, we're now going to differentiate that with respect to y this time instead of x. And that turns out pretty nice. We get negative x, which is just derivative of that piece, and then plus g prime y. And oh wow, they match. Okay, great. They match up exactly. So we know that the constant function g here must be 0. So our answer is just that function. I'm going to go ahead and cheat a little bit here. We know that that's 0, and just make that equal a constant, and we're done. So this equals, not 0, equals a constant, and we are done. All right, so that is the relationship between x and y that would satisfy that differential equation. Just double checking my work here, my answer. Okay, we're good. All right, what was that? That was 13. Let's look at number 14. So 3x squared y. And then we have plus e to the y and dx plus x cubed plus x e to the y minus 2y dy equals 0. Hope you don't mind me double checking, make sure I wrote it all down right. Wouldn't want to get halfway through this and realize I wrote it down wrong. Okay, we're good. So we have m here and n here. All right, partial of m with respect to y is just 3x squared plus e to the y. Partial of n with respect to x is 3x squared plus e to the y again. All right, we're good. It's an exact equation. So the partial of f with respect to x must match up with m. So here it is. Integrating with respect to x, we get x cubed y plus, now e to the y is a constant, so this is just going to be x e to the y plus g of y, some function of y. We differentiate now with respect to y, and we get x cubed and plus, well, x is a constant here, so take derivative of e to the y, that's itself, and then plus g prime y. Does it match exactly? No, it does not. So this time we just have to figure out, we're basically going to be figuring out what's missing, all right, which I'm sure you could just look and see what's missing, but I'll write it down this time. In the future, if I can just look up there and see what's missing, that's what I'm going to do, just to save some time. So we needed this to match up with this. So the x cubes are gone, x e to the y's are gone. So that means that g prime of y would need to be negative 2y, which means that g of y is negative y squared plus a constant. We don't care about the constant anymore. So now we're ready. We can just come here to f. It's x cubed y plus x times e to the y, and then our function of y, which we just determined was minus y squared. So that must equal a constant, so there it is. Check my answer. Looks good. All right, number 15. One minus 3 over x plus y. You got? Yeah, all right. dx plus 1 minus 3 over y plus x dy equals 0. All right, double check it. Looks good. And now we proceed. This is m, this is n, and whoa, that's a big line. All right, partial of m with respect to y is just 1, yay. Partial of n with respect to x is just 1, yay. All right, we're in business. Partial of f, I guess I should be saying a if it was not exact, then we could just go to the next problem. This should be minus 1 minus 3 over x plus y. Integrate that with respect to x, we get x minus, be careful here, 3, I said 3, I wrote natural log 3, natural log x, and then plus xy, and then plus some function of y. Partial of that with respect to y is just x plus g prime y. And boy, we're missing a lot of stuff, but I told you I was going to kind of take a shortcut here. So we have an x, we have the x up there, okay? The things we're missing are these two pieces. So that means g prime of y has to be equal to 1 minus 3 over y. And that means g of y, when I take the antiderivative, must be y minus 3 natural log y. And so our original function here, f, I'm going to replace the g right there with y minus 3 natural log y. That must equal some constant. And remember, I'm erasing f at the front because I have an equation equal to, or I have an expression equal to a constant. So there we go. Check it real quick. X plus y plus xy. Yeah, okay. The book puts these logs together. They write that as minus 3 times natural log x plus natural log y, and then they put these two logs together to make it natural log xy, and they put the minus 3 out front, but who cares? All right, I think I can do one more before I have to go to class. 16. Okay, working number 16 here. We have e to the y plus 2xy cosine hyperbolic of x, and then y prime plus xy squared sine hyperbolic x plus y squared cosine hyperbolic x equals 0. All right, so remembering that this y prime here is really dy over dx, we can multiply everything by dx. I'm multiplying this, 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 and this by dx. So this can turn into dy. And since both of these terms here get dx on them, I'm just going to slap the dx outside with the parentheses. And now we have something that looks a little more like our formula, or the standard form that we've been using here. So the first step for us is to just be careful that this is m, all right, because it's in front of the dx, and then this one is n. All right, so now we push through. We are going to take the partial of m with respect to y. So we're treating x and sine hyperbolic x like a constant. So derivative of that is just 2 comes off the y, 2xy sine hyperbolic x. And then over here, we take derivative with respect to y, and we get 2y cosine hyperbolic x. And now we take the partial of n with respect to x. So here's n. So derivative of that's 0. And when I take the derivative of this with respect to x, notice I have a product right here. So I have to do derivative of this one, which is just going to be 2y cosine hyperbolic x, and then plus, now derivative of cosine hyperbolic x is sine hyperbolic x. There's no negative there. And then times this, so 2xy, like that. All right, so that matches. This is this, and this is this. So it is an exact equation, so we can proceed. So I know the partial of f with respect to x must be equal to this guy right here. All right, be careful. X y squared sine hyperbolic x plus y squared cosine hyperbolic x. And now I'm going to integrate with respect to x. So I get just f here, and then here, let me see. This one, this second term right here will be easier because the y squared is a constant. So I'm just going to put y squared, and the antiderivative of cosine hyperbolic x is sine hyperbolic x. And then on this one, the y squared is going to come for the ride, and then I still have the x and the sine hyperbolic x. So I'm trying to integrate x sine hyperbolic x dx. So a quick little integration by parts, x sine hyperbolic x dx. This is cosine hyperbolic x. This is dx. And so that should just come out to be x cosine hyperbolic x minus the integral of cosine hyperbolic x, which is x cosine hyperbolic x minus sine hyperbolic x. All right, so that's all in front of the y squared. So I'm going to say y squared x cosine hyperbolic x, and then I would distribute that y squared through, so I get y squared. Oh wow, what the heck just happened? Wow, okay. I think I've seen that happen. Let me try this again. Let me do, I'll just put it in parentheses. Okay, so there we go. Now, we're going to take the derivative of this with respect to y now and hope that it matches up with this and see what we're missing there. So when we do that, we get, let's see, 2y, and then I'm going to distribute now x cosine hyperbolic x minus 2y sine hyperbolic x plus now 2y sine hyperbolic x. All right. So now, hold on a second. Okay. All right, so now when we look up here, let me look at that yellow up here. I have the 2xy cosine hyperbolic x. I have that, so that's gone. But, and then these two cancel, which is nice. So the only thing I'm missing is this. So that means that, oh, I forgot my g y here. Oops. Okay, so when I differentiated, I should have g prime y here. Okay, that's what we've been doing. I just forgot to put it there. And so we know that the only thing we're missing is this e to the y. So that means that g prime of y must be e to the y. And that means g of y has to be e to the y plus some constant that we're not going to care about. Which means that the original function f needs to be, I'm going to erase the f here, I'm going to replace the g of y with e to the y. And this equals 0. So that's the relationship between x and y that we need in order for this to work. Now, I should have noticed this. If I would have distributed, which I tried to do, and then my computer acted funny, the next term here, minus y squared sine hyperbolic x, would cancel with this one. So when I distribute through, I'm basically going to kill this off and this off. And so these are gone. So really all we have at the end of the day is y squared x cosine hyperbolic x plus e to the y equals 0. Okay, and that should be it for that one. All right, next one, try and get into a groove here. Number 17. we have x squared y cubed minus 1 over 1 plus 9x squared, all of that dx dy, and then plus x cubed y squared equals 0. All right, so we multiply everything by dy first, so that means this will be dx, and then over here next to this will be dy equals 0. So like we did before, we got to make sure that the m is in front of dx, so this is m, and then this right here is n. So the partial of m with respect to y is just going to be 3x squared y squared. The partial of n with respect to x is just, again, 3x squared y squared. So we check out, that's an exact. So I know that the partial of f with respect to x should equal m, which is this. And then when I integrate, I get, let's see, I'm treating y like a constant, so I get 1/3 x cubed y cubed. Hold on, someone's at my office door. Okay, sorry, I had a student come by. All right, so we take derivative with integrate with respect to x, and we've got that. And then on this one, we need to go to a formula. And first thing I'll do is I'm going to have to factor a 9 out of the bottom. So it's going to become like we're trying to integrate 1/9 integral of 1 plus, we're going to have, since we pulled out 9, I'm going to have 1/9 here and then plus x squared. So this looks like a formula that we should recognize for arctan. So this right here is a squared, so that means that a is equal to 1/3. And then we just reference the formula in case you don't remember it. It is on, oh, that's right, you're in a different class. I was going to tell you what page to go to, but never mind. So the antiderivative of this, we have the 1/9 out front, and then it'll be 1 over a, so 1/3, 1 over 1/3, arctangent of, in this case, x over 1/3. And remember, 1 over 1/3 is just 3. So this is just 3. And then this one over here, I'm just going to put a 3 up here instead. And then 1/9 of 3 is 1/3. So 1/3 arctangent of x over 3. Oh, sorry, 3x. Okay, that is the antiderivative. So minus 1/3 arctangent of 3x. And then we have possibly some function of g here. So now what we do is we take derivative of this with respect to y. And when we do that with respect to y, let's see, the only thing we have to worry about is this y coming out, so, or that 3 coming out. So we're going to have x cubed y squared. And then taking derivative of this with respect to y is gone, so then we just have plus g prime y. And that needs to match up with this, which it does exactly so long as this is 0. So that means g prime of y is 0, which implies that g of y must be a constant, which we don't care about. So our final answer is that the equation is going to be g of y is 0, so don't care, equals 0, and then everything just the way it appears right here. So that is going to be number 17. And I've got to get to class, so that'll be it for now. Okay, let's take a look at number 18. We have 5y minus 2x, y prime equals, or minus 2y equals 0. And remembering y prime is dy dx. And multiplying everything by dx. We'll just get a dx right there next to that 2y. and then the other side's still 0. And so we need to just identify what m and n are, and just remember that the m is in front of the dx, so that's our m, and the n is in front of the dy. All right, so now we check to see if it's an exact equation, so we're going to take the partial derivative of m with respect to y, which is just -2. So just keep in mind here, this right here is really plus -2y, like that. And then the partial derivative of n with respect to x, we also get -2. So it is exact. And make sure my microphone's working here. Yes. All right, and now we go ahead and say that the partial of f with respect to x must be m, so that's -2y. Integrating with respect to x, we get -2yx plus some possible function of y. And then we differentiate that with respect to y, and we get -2x plus g prime of y. And then we go and we compare it. Up here, we can see that we have the -2x, but we're missing the 5y. So that means that g prime must be that 5y. And that means that g of y is equal to 5/2 y squared when we integrate it, plus a constant. We don't care about the constant. So that means this right here can be replaced with 5/2 y squared. Then we can erase that f and put equals a constant. So that is it for number 18. Okay, let's look at 19. We have tan x minus sine x sine y dx, so that's our m, plus cosine x cosine y dy equals 0. All right, so let's take the partial of m with respect to y. And so we're just going to be differentiating that sine y, which is cosine y, but we still have the negative sine x in front of it. So we got that. Take my watch off. Okay, and then we take the partial of n with respect to x. So all we're going to do is differentiate that. That gives us negative sine x. And that cosine y we're treating like a constant, so that works. It's an exact equation. So now we can write that the partial of f with respect to x is the m, which is that one. And so that's tan x minus sine x sine y. Integrating with respect to x, we get, so we have to take the antiderivative of tangent of x. So there are formulas for all of the antiderivatives of the 6 regular trigonometric functions. This turns out to be natural log of secant x. And then minus, now remember sine y here is a constant because we're integrating with respect to x. So I just need the antiderivative of, I'll look at it as negative sine x, which is exactly cosine x. So I'm just going to put plus cosine x sine y, like that. All right, plus some possible function of y. Now we differentiate this with respect to y. We get 0 in that first term, and then the only thing is that cosine x is a constant, and then derivative of sine of y is cosine of y, and then plus g prime y. And we'll try and match this up. We see what we're missing, cosine x cosine y, but that's exactly what we have here, which means g prime of y is a constant, or yeah, is 0, sorry. G prime of y is 0, which means g of y is a constant. We've already seen whenever this happens, we just kind of ignore it, erase it here, and that's because this is going to be equal constant anyway. There, so that's our answer We have natural log of secant x plus cosine x sine y equals a constant. Okay, working number 20 here. We've got m here and n here. So let me start by taking the partial of m with respect to y, which is just 0. And then if I take the partial of n with respect to x, I also get 0. So it's an exact equation. So the partial of f with respect to x is equal to this whole thing, 3x cosine 3x plus sine 3x and then minus 3. So I'm going to integrate this with respect to x. So let me take care of these n pieces first. The antiderivative of sine of 3x is negative 1/3 cosine 3x. There's a little bit of chain rule there involved, but I can assume that you can do that. Minus 3x. And then we need to find the antiderivative of this. So let me just jot that down over here. I have integral of 3x cosine 3x dx. Going to need integration by parts. So I'm going to use 3x here, cosine 3x dx here. The antiderivative of cosine 3x is 1/3 sine 3x, and the derivative of 3x is 3 dx. So I'm going to have this times this, which is just going to give me sine x sine 3x, and then minus the integral, and now I'm going to multiply these two, so I just get sine 3x dx. And so now I've got x sine 3x, and then the antiderivative of sine of 3x is negative cosine of 3x. Negative 1/3 cosine 3x, but I already had a negative out here, so it's going to become plus 1/3 cosine 3x. All right, so that goes here, x sine 3x, and then plus 1/3 cosine 3x. And I'm very happy to see that because that's going to cancel. And so we get that f is really just x sine 3x minus 3x plus some function of g. I forgot to put that up here, but when we're integrating, we can always have some function of g possibly. So now we take derivative with respect to y, and all I get is g prime of y, and that has to equal this. So that means g of y is equal to y squared plus 5y. And so now I can rewrite f, and I can replace this g of y with y squared plus 5y, and that must equal some constant. I'll erase the f out there. All right, so there it is right there. Okay, number 21. Actually, I need to start this over. Let me see, I have 1 minus 2x squared minus 2y dy dx equals 4x cubed plus 4xy. Now I multiply both sides by dx, so I get dy here and then this whole thing dx. And then I'm going to move this to the left side of the equation, which makes it a minus, and then equals 0. And then I remember in the formula this has to be a plus, so I'm going to just move that minus right here, change that to a minus. So this is m because it's in front of dx, and this is n. The partial of m with respect to y is equal to negative 4x, and the partial of n with respect to x is also negative 4x, so it's an exact equation. The partial of f with respect to x must be m. Now if we integrate this with respect to x, we get just negative x to the 4th, and then minus 2x squared y plus some function of g. And now if we differentiate that with respect to y, we just get negative 2x squared plus g prime of y, and that must match up with this. So that means we have this, we're missing the 1 minus 2y. So that means that g prime of y must be 1 minus 2y, and that means g of y must be y minus y squared. And so our f function, I can replace this g here with y minus y squared, and that must equal some constant right there. All right, so let me just check that. X to the 4. Okay, good. Now moving on, 22. So 22, all right, we've got 2y sine x cosine x, 2y sine x cosine x, and then we have minus y plus 2y squared e to the xy squared dx, so that's my m, equals x minus sine squared x minus 4xy e to the xy squared dy. So we will move this over to the other side, so that will make it negative, and then this will be equal 0. And then I need this to be a plus, so I make that plus, I make that negative, I make that plus, I make that plus. And now I have m here and n here. So the partial of m with respect to y is equal to, well, y is the only thing here, so everything else is a constant. So it's just 2 sine x cosine x minus derivative of that is just 1. And then here, oh man, we have product rule. We have to do a product right there. So we're going to say plus 4y e to the xy squared plus the derivative of e to anything is itself, e to the xy squared, times the derivative of the top right here, or the exponent with respect to y, so x is like a constant, it's going to give you 2xy. Alright, so that's the product rule there. Now let's try and take a look at the partial of n with respect to x. Okay, so derivative of that is just negative 1. And derivative of sine squared x is 2 sine x, that's power rule, times the derivative of sine, which is cosine. Okay, got that. And then plus, and then over here, again, we have a product rule right there. So we do derivative with respect to x of 4xy, which is 4y, times e to the xy squared, and then plus derivative of e to the xy squared is this, times derivative of what's up here with respect to x, which is just y squared, and then times the original function 4xy. You know what, I think on that previous product rule, yeah, I did forget it. Right here, on this one, I forgot to finish off the product rule. I still needed the 2y squared to be here, 2y squared. Alright, so let's see what's the same here. We've got negative 1, negative 1. We've got 2 sine x cosine x, 2 sine x cosine x. 4y e to the xy squared, 4y e to the xy squared, and then e to the xy squared, e to the xy squared, times y squared times 2xy, and then another 2, so that's 4, so 4xy. Yes, they match up exactly, so they are exact. Now, the fun part. The partial of f with respect to x has to be equal to m, so that's 2y sine x cosine x minus y plus 2y squared e to the xy squared. So if I integrate this with respect to x, I need to do some work here. Now, I just want to point out, and I noticed this in the very beginning, and I thought about switching it over. This 2 times sine x cosine x is actually a Pythagorean, it's actually an identity from pre-cal. That's actually equal to sine of 2x. So I'm going to replace that with sine of 2x, just to make my differentiation easier. So or integration easier, when I integrate this with respect to x, I'm going to get a negative 1/2 y cosine of 2x. So that's the antiderivative of sine of 2x, and the y just came along for the ride. So still integrating here with respect to x, I get minus yx, and then plus the 2y squared comes for the ride. Now I need to take the antiderivative of e to the xy squared. And just remember that y squared is like a constant. So the antiderivative of that should be itself, but then I need to scale it by 1 over y squared. And that's because when you take the derivative of this with respect to x, you get a y squared pop out, and we want it to not be there. So that's it. Oh, this should have been times right there. So I had my 2y squared right there, that was a constant, and then the antiderivative of that's right there. All right, now I do get some things to clean up here. I do get these y squareds to cancel. So that's just 2e to the xy squared. And then I still have plus some function of y. Now, I take the derivative of this with respect to y. So let's see, y is the only constant there. I get negative 1/2 cosine 2x, and then I get minus x, and that's derivative with respect to y, and then I have to take derivative of all of this with respect to y. So it's itself times derivative of what's up here with respect to y, which is 2xy. All right, what do we have here? I think that identity is going to mess things up now. Oh, man. Let's see, I need that to match up with this. So negative x, negative x. Yeah, that identity is going to mess things up. That identity that I used there. All right, well, let me do this. I'll switch it back. So if I go to my pre-cal identities, my double angle identities from pre-cal, I have 3 different identities I can use for that. So why don't I use the one where that's 1 minus 2 sine squared x. So if I do that, and then I multiply through by the negative 1/2, I get negative 1/2, and then here to here, the 2's cancel, get plus sine squared x. Okay, so the way we can look at this is that this right here is actually this, and you can see the sine squareds, we don't need them. And then the constant we don't need to worry about, because we're going to be adding constant anyway, so we can just ignore that. And then this right here is exactly this right here. So there's nothing missing. Okay, everything is there. So that means that, oh, and I forgot to put g prime y here. So that means that g prime y is 0, which means g of y is a constant. So our answer should be, and I'm going to write it down, our answer should be negative 1/2 y cosine 2x minus yx plus 2e to the xy squared must equal some constant. And that's just this line right here. Now let me just check this one because that looks a little messy. Yeah, it's going to be different from the back of the book because, again, they use this identity here. They switched that over. But it's correct still. So we should be good to go. Yeah, all right. Okay, moving on to 23. For x cubed y minus 15x squared minus y dx, so that's m, plus 4x, x to the fourth plus 3y squared minus x dy must equal 0. So there's our m, there's our n. So partial of m with respect to x, I keep doing that, y is 4x cubed and then minus 1. Partial of n with respect to x is 4x cubed and then minus 1 again. So it is exact. Partial of f with respect to x must be m, so that's 4x cubed, y minus 15x squared minus y. So we integrate that with respect to x, and we just get x to the fourth y minus 5x cubed minus xy plus some possible function of y. That was just f. Partial of f with respect to y would then be x to the fourth minus x plus g prime of y, and we're trying to match that up. So we got x to the fourth minus x. So you can see here that the only piece missing is that. So that means g prime of y must be 3y squared, which means that g of y is just y cubed. So coming back up to f, I can replace g of y and replace it with y cubed, make it equal a constant, and that is the solution. Checking it real quick. Okay, looks good. 24. Oh man, that looks bad. So we have 1 over x plus 1 over x squared minus y over x squared plus y squared dx, so that's m, plus y e to the x, oh no, e to the y, plus x over x squared plus y squared dy must equal 0. Alright, here's m, here's n. Partial of m with respect to y is equal to, well, these two go to 0, so we don't worry about those. This is a quotient rule, so let me do the derivative of that. So the derivative of the top is 1 with respect to y, times the bottom, minus the derivative of the bottom with respect to y is 2y, times the top, all over the bottom squared. Which is just x squared plus y squared minus 2y squared. So we should just get x squared minus y squared on top over x squared plus y squared squared. Alright, the partial of n with respect to x is just quotient rule here. So it's going to be kind of the same story. Derivative of the top is 1 times the bottom minus derivative of the bottom with respect to x, which is 2x times the top, all over the bottom squared. Okay, which is, alright, so when we do this, we get x squared plus y squared minus 2x squared, which would be y squared minus x squared over x squared plus y squared squared. Now, those are off by a sign. Make sure, oh, yeah, okay, sorry. That was a minus there. So this whole guy right here needs a negative in front of it. Right there, which is going to distribute up here, make that basically a minus x squared and a plus y squared. Okay, so they do match. Alright, now let's go ahead and figure out that the partial of f with respect to x is m, and m is that first one here, so let me let me rewrite that as x to the negative 1. I'll leave it as 1 over x because we're going to integrate it, so I can integrate 1 over x. I'm going to write the next one as x to the negative 2, so I can use the power rule, and then y over x squared plus y squared. All right, so we're going to integrate. F must be antiderivative of this stuff with respect to x is natural log of x, okay, minus x to the negative 1. And then minus, now look, the y is going to come out because it's a constant. That's the y on top. And so I'm really trying to integrate 1 over x squared plus y squared dx, and I'm treating my y like a constant. So that looks a lot like the formula like a squared plus x squared dx, right? And that's arctangent. The antiderivative, that's arctangent. So we're going to now have 1 over a arctangent of x over a, like that. So that's the formula for that. So for us, the antiderivative of this is going to be 1 over y arctangent of x over y, like that. Okay, so that goes right here. So we have 1 over y, and that's nice, arctangent of x over y, and then we still have plus some function of g, or some function of y. These y's cancel. So now we take the partial of this with respect to y, and we get 0, 0, and then, let's see, we have to take derivative arctangent of this. All right, so derivative arctangent of something is 1 over 1 plus what's inside the argument squared, so I'm going to square top and bottom, times the derivative of what's in here. So for that, I want you to look at that as being x, y to the negative 1, because we're differentiating with respect to y. So x is like a constant, so we're going to get derivative is negative x, y to the negative 2. And then we still have plus some, the derivative of g, so g prime y. Now, we're supposed to try and match this stuff up here in this one, right? But what we have down here looks pretty ugly. So let me just verify that. I feel like we're missing a sign here. I did it again. Okay, so that sign right there needs to come with us. So that I'm going to put it here. Okay. Because I had just taken the derivative of that, right? I had just taken derivative of that, and I never accounted for the minus that was in front. Okay, so when we do this, you're basically going to have a positive 1 on top, because negative and negative. And this y to the negative 2 goes on the bottom as a y squared. So it's really like over y squared. And then you can distribute that y squared through the bottom. And what you get is y squared plus, and then the x squared over y squared times y squared, the y squareds cancel, so you get that. So that's what we have, and then we have plus g prime of y. So when we now go back up here and we look, and we try and, oh, that was an x on top. X, don't forget that x right there. So you can see that this and this match, and so the only thing we're missing is this. So that tells us that g prime of y equals y e to the y, and then to get g, we just do an integration by parts. And so when we do integration by parts, and I won't show it, we get y e to the y minus e to the y. So that's what that needs to be. So at the end of the day, f, which is this right here, is equal to, well, I'm just going to write it as the equation. So natural log x minus x to the negative 1, 1 over x, and then we have minus arctangent of x over y, and then we had plus g of y, which was turned out to be y e to the y minus e to the y. That must equal some constant. Whew, okay, I think I should check that. We're good to go. Okay, number 25. So we're going to switch gears here now, and we are going to be solving differential equations, but now we're going to be given an initial condition. So we should be able to nail down the exact curve that satisfies the differential equation and passes through some specific point. So here's the first differential equation, and then the given condition is that y of 1 equals 1. So when we plug in 1 for x, we should get out 1 for y. So I'm not going to check that this is exact, okay? Let you do that yourself. Assuming that this is exact, we have, this is m, and this is n, so we know that partial of f with respect to x has to be x plus y squared, that whole thing. And then the antiderivative of that is going to be 1/3 x plus y cubed. And then if we take the derivative of that with respect to y, we get, oh, I forgot my g of y here. The derivative of that with respect to y would be a little power rule there, and then derivative of the inside is just 1 plus g prime y. And it might be a little hard to see what's going on, so I'm going to expand this. Okay, so that piece right there needs to match up. So we have x squared already, we have 2xy, but we've got some other stuff there that doesn't match. So I'm going to say this. I'm going to say we need y squared plus g prime y, okay, to be equal to that -1 right here. Everything else we have, so we don't have to worry about it. It would just cancel from both sides. So g prime of y would be -y squared, taking the y squared to the other side, minus 1, which means g of y would be -1/3 y cubed minus y. So that means our equation up here, I can erase this, that would be replaced with -1/3 y cubed minus y. That must equal some constant, right? So that would be our general solution, which will give us a family of curves. But now we need to nail down what that c is. So now I'm going to replace all my x's with 1 and all my y's with 1. So if I do that, I get 1/3, and then x plus y is 1 plus 1, that's 2 cubed. Then minus 1/3, and then we have y cubed, that's 1 cubed, that's just 1. Then minus 1 again, that must be a constant. And so we have 8/3 minus 1/3 minus 1, and if you compute that, you just get 4/3 is c. So if I go back to this equation and replace that c right here with 4/3, then that is our specific curve right there. Okay, next, 26. So 26, we have e to the x plus y, and then dx, and then plus 2 plus x plus y e to the y dy must be 0, and y of 0 is equal to 1. All right, so now we go in, and again, it's exact, so I know partial of f with respect to x must be the e to the x plus y. The antiderivative of that with respect to x is itself e to the x plus xy plus some possible function of g. And now if I differentiate that with respect to y, we get just x plus g prime y. So you can see here I have x here, so the only thing missing is these two. So that means that g prime of y is going to be 2 plus y e to the y. And if we integrate that with respect to y, we should get 2y and plus e to the y, or sorry, y e to the y minus e to the y. Let me just think about something for a second. Yeah, okay, so that's it. So now f, we come back up here, replace that with y e to the y minus e to the y, that must equal some constant. So I'm going to erase that there. There we go. And now, using this equation, I can plug in for x0 for y1 and see what we get for c. Do that down here. So we get e to the 0 plus 0 times 1, which is going to be 0, plus 1 times e to the 1 minus e to the 1 equals 0. Equals c. And so up here in front, that's a 1 plus 0, who cares? And we have plus e minus e. And that means that c should just be, what am I missing here? Missing a 2y. Where's, oh, there it was. Okay, that's right. Oops, I needed to put that up here. Plus 2y equals c. Okay, so when I plugged in here, I'm missing in here plus 2 equals c. So I plugged in for that one right there. So we should have a plus 2 here equals c, and then the e's cancel and you just get 3 for c. Okay. Now, okay, working 27 here. All right, we've got 4y plus 2x minus 5 dx plus 2 plus x. Oh, no, hold on. I started writing down the wrong problem. 6y plus 4x minus 1 dy equals 0. And we have y of 0, no, y of negative 1 equals 2. All right. Here's m, here's n. It's already exact. I'm not checking it. So partial of f with respect to x is equal to 4y plus 2x minus 5. And that means that f is equal to 4xy plus x squared minus 5x plus some function of y. Now partial of that with respect to y is 4x plus g prime y. And that must match up with this up here, but I already have the 4x, so that just means that g prime of y is everything else. So plus 6y minus 1, and that means g of y is equal to 3y squared minus y. So I can rewrite this f with 3y squared minus y here equals a constant, and now I can start plugging in x and y. So x is going to be negative 1, y is 2, negative 1 plus 3 times 2 squared minus 2 equals c. And now we get negative 8 here, we get plus 1, we get plus 5, we get plus 12 minus 2 equals c. And that gives us negative 7 plus 17 minus 2, which is going to be 8. C is 8. All right, so if we replace this c here with 8, we've got our answer. Okay, so this is number 28. I've already written down here. This is our m. This is our n. So not going to check that it's exact. We'll just trust that it is, even though that would take a little bit of work to show. And so now let's go ahead and proceed. We've got partial of f with respect to x must be m. So I'm going to write that as, I'm going to write it this way, 1/2 x y to the negative 4, like that. And now that means f, if we integrate this with respect to x, we get, let's see, 1/4 x squared y to the negative 4 plus some function of y. And then if we take the derivative of that with respect to y, we get negative 4 comes out, so we get negative x squared y to the negative 5 plus, I don't know why I put the prime there, g prime of y. And now we need to look at n up here and see if we've got this. And notice that I could split that into two fractions. I could write that as 3 over y cubed minus x squared over y to the 5th. And so we actually have the minus x squared over y to the 5th minus x squared over y to the 5th right there. So the only thing we're missing is this right there. So that means that g prime of y is just 3 over y cubed, so 3y to the negative 3. And that means g of y is going to be equal to, let's see, negative 3 halves y to the negative 2. So if we differentiate that, we should get back up there. So that's g of y, so I'm going to put that right here. I'm going to write it as, put it in here as minus 3 over 2y squared. And I'm going to rewrite this right here as over y to the 4th. And this is equal to some constant, and I'm going to plug in 1 for x and 1 for y. So when we do that, we get 1/4 times 1 over 1, so that's just 1/4, minus 3 over 2 times 1 squared, so that's just 3 halves, equals c. And that's the same as 1/4 minus 6/4 c. So we get negative 2/4, negative 5/4 should be c. All right, what was this number? 28. Yeah, so we replace this here with negative 5/4, and we're in business. All right, 29. Y squared cosine x minus 3x squared y minus 2x dx plus 2y sine x minus x cubed plus natural log y dy equals 0. And then we have y of 0 is e. All right. We will assume that it's exact, although you need to be checking that. Let me just make sure it is. Okay. All right, so partial of f with respect to x should be the m. This is m. So y squared cosine x minus 3x squared y minus 2x. So that means if we integrate with respect to x, we get y squared sine x minus x cubed y minus x squared plus some function of y. Differentiate that with respect to y, we get 2y sine x minus x cubed plus g prime of y. So now, let's see what we've got here. Looking at n, we got 2y sine x, got minus x cubed, but that means that g prime of y has to be that natural log of y thing. And then if you integrate this, you can do that using integration by parts, or you just know a formula. It's y natural log y minus y. So since we have that as our g, we plug that in right here. Y natural log y minus y equals some constant. I erase that f. And now we'll go and plug in. So we're replacing y with e and x with 0. So e squared sine of 0 minus 0 times 0 cubed, that's all gone, so who cares about that? And then 0 here, it's gone. And then we have e times natural log e minus e equals c. All right. Sine of 0 is 0, so that's gone. Natural log of e is 1. So we get minus e equals c. So negative 2e equals c. Wait a minute. Oh no, did I miss something? Was x 1 or 0? X was 0. Okay, let me just check my y squared cosine. Cosine. Where is that? Y squared sine x minus x squared sine minus x squared plus minus y. That's all right. Okay, so I've got this right. Something am I plugging in here? E squared sine of 0 minus, oh, this right here. Duh. Okay, so this right here, well, no, this right here goes to 0. So this is gone, this is gone, this is gone. These are all gone. So we've got, oh, I put a plus, man. I put minus there. This should be plus. Plus, there it is. So we get e plus, we get e minus e. That should be 0. Yes, okay. E minus e, 0. There we go. Sorry about that. All these little algebraic, little arithmetic issues. Okay, 30. We have 1 over 1 plus y squared plus cosine x minus 2xy dy dx equals y times y plus sine x, and then y of 0 is 1. All right, multiply both sides by dx. Dx. So you get this. And then let's move this term over here to the left, so it's going to become minus and then equals 0. And then remember that minus needs to go through to make this a plus. So plus, and then this thing will have a negative in front of that y, and that should do it right there. All right, so this is m, and this is n. And assuming that it is exact, I know partial of f with respect to x is negative y, and then y plus sine x. And if you want, you could rewrite that as negative y squared minus y sine x. And that means when we integrate with respect to x, we get negative xy squared. And this should be plus y cosine x plus some function of y. So y here was negative y here was a constant, and then we just integrated, well, yeah, we integrated sine, which gave us negative cosine, and then we already had a negative out there. So, all right, that's good. Now, partial of f with respect to y is going to be negative 2xy, and then plus, this is just cosine x, and then plus g prime y. Now, let's see what we've got. Cosine x, minus 2xy, minus 2xy. So that means that g prime y is anything that's left over up there, which is 1 over 1 plus y squared. So that means g of y is arctangent of y. And so I can rewrite this, arctangent y, and that must equal some constant. So now let's plug in. Going to replace x with 0, y with 1. So that first term goes away. All right, if I replace this with 1 and this with 0, cosine of 0 is 1, and then y is 1, so 1 times 1 is 1. Then plus arctangent of 1 equals c, and that's just saying at what angle is tangent 1, and that means the ratio of opposite over adjacent must be the same or equal, and that happens at pi over 4, and then plus 1 out here. So our C should be pi over 4 plus 1. All right. That works. Looking good, looking good. All right. Okay, going to be working on number 31, and again we switch gears. Slightly different problem. We have y cubed plus k, so this is the first time we've seen this, kxy to the 4th, and then minus 2x dx, so this is our m, and then plus, in parentheses, 3xy squared plus 20x squared y cubed dy equals 0. All right, so what we're asked to do here is find the value of k. So we want to find the value of k so that the given differential equation is exact. So for it to be exact, the conditions we need are that the partial of m with respect to y is equal to the partial of n with respect to x. So we just need to make sure that equation is satisfied. So let's take the partial of m here with respect to y. So we get 3y squared. Now, k is a constant that we're trying to find. So k is a constant and x is a constant because we're differentiating with respect to y. So that 4 will come out. We'll have the kx and then y cubed. And then the derivative of negative 2x is 0 with respect to y. So we need that. We're kind of a question. We need this to be equal to now the partial of n over here with respect to x. So if we differentiate with respect to x right here, all we get is 3y squared. And if we differentiate with respect to x here, we get, let's see, plus, that 2 drops out, so 40xy cubed. And as you can see here, these two are the same. And we just need these two to match up. So what we would need is for k here to be 10, and that way we would get 40 xy cubed, and it would match this. So k would need to be equal to 10. Let me see here. Number was this. Oh, I was looking at the wrong one. Yes. Okay. Now 32. I'm only going to do 31 and 32 here because these are pretty straightforward so far. 32, we have 2x minus y sine of xy, so that xy is inside the argument of sine, and then plus ky to the 4th, all of that dx, so that's our m. And then we have minus, so I'm actually going to put plus and distribute the minus through. Minus 20xy cubed, and then I distributed the minus x sine xy dy equals 0. Okay, so here's m, here's n, and same thing from before. I'm going to take, I need the partial of m with respect to y to be equal to the partial of n with respect to x. So the partial of m with respect to y is going to be, let's see, derivative of 2x is gone, and then here we have a product rule, so we have to, and we have a minus out front, so I'm just going to do it this way, minus, now here comes my product rule. So derivative of y is 1 times sine of xy plus derivative of sine of xy is cosine of xy, then times the derivative of what's in here with respect to y, which is x, but then also times the y from the product rule. All right, that is our derivative of that product there. Now we need to take derivative of this with respect to y, so we get plus 4k y cubed. All right, oh, and I needed to close off that minus sign, closes off there. Okay, so we really have negative sine of xy minus cosine, you know what, let me do it this way, minus xy cosine of xy, plus 4k y cubed is the partial of m with respect to y. Now, we need that to be equal to the partial of n with respect to x. So a derivative of that right there is negative 20 y cubed. And then, again, we're going to have a product rule here. We have a minus. I'm going to just take that minus out. Derivative of x is 1, so we get sine of xy, plus derivative of sine of xy is cosine of xy, times derivative of what's inside here with respect to x, which is y, then times the first function to finish off product rule. So that is that. And if I distribute the minus through, I get minus there, and then this becomes minus, and don't need that bracket anymore. So let's see what we've got here. Well, we know that this guy and this guy cancel each other out, so those are the same. And then we have these are the same, so they cancel out. So the only thing is we need these two to be equal, right? So we need 4k y cubed to be equal to negative 20 y cubed. And you can divide both sides by y cubed, and you can divide both sides by 4, and you get k is negative 5. So k would have to be negative 5 in order for this to be an exact differential equation. All right, that's it for that. Okay, we're going to, again, switch gears. We're going to do number 37. And for this one, we've got 6xy dx plus 4y plus 9x squared dy equals 0. And then they give us this function here of x and y, which is just y squared. And what they are asking us to do here is use this, what we're calling an integrating factor, to solve the differential equation. So let's just show first that if we call this m and this n, then if I take the partial of m with respect to y, I get 6x. If I take the partial of n with respect to x, I get 18x, and these are not equal to one another. So it's not an exact differential equation. So what we can do is, if we can come up with an integrating factor, and we will discuss later how to come up with that, then what we can do is we can take the original differential equation and just multiply both sides of the equation by that integrating factor. So if I multiply everything by y squared, I get a new differential equation. Looks like this. Okay, so I've multiplied everything by y squared. Now, if I look at this and call this m now, and this n, then let's just check. What's the partial of m with respect to y? Well, we get 18xy squared. If we take the partial of n with respect to x, we get 18xy squared. So now we do have an exact differential equation, and all it took was us multiplying by this very clever y squared. Now let's actually find the solution to this. So what we do, go back to what we were doing before, and we will say that the partial of f with respect to x is m, so 6xy cubed. We integrate with respect to x, and we get 3x squared y cubed plus some possible function of y. Now we differentiate that with respect to y, and we get, let's see, 9x squared y squared plus g prime of y. And we look up here and we see that this and this match, so that means that g prime of y must be 4y cubed, and that means g of y, if we integrate with respect to y, is just y to the fourth plus some constant. Remember, we were saying that that constant was 0. And so our original function here, if we rewrite this as 3x squared plus y cubed plus g of y, which we got y to the fourth, and then this must equal some constant. And this would be the relationship between x and y that should satisfy this differential equation. But now we can show that it also satisfies this one. So let's see, do I want to go through that? Yeah, I can go through that. Let me erase this stuff here. Let me just show that that's a solution, that we didn't lose anything by multiplying by y squared. So I'm going to take my original differential equation, 6xy, and then dx. So we need to come here, and you know what, let's do it this way. Let's do it this way. Let's divide everything by dx. So divide through by dx, we get dy dx right here. So I'm going to replace this with dy dx, and I'm going to take this right here and find dy dx. So I take the derivative of that implicitly and with respect to x, and I get, let's see, 6x y cubed plus 4y cubed times dy dx equals 0. So just remember, when I'm taking derivative of this, I'm treating y like a constant. Oh, you know what? Hold on. I messed this up. Let me do it again. Should not have done that. Cubed. I'm doing implicit differentiation, so I have a product rule here. So derivative is 6x times y cubed plus, now derivative of y cubed, which is 3y squared dy dx, times the first function, 3x squared, and then plus 4y cubed dy dx equals 0. Now if we solve this for dy dx, we're going to get 3y squared, I'm just going to put y prime instead of dy dx, plus 4y cubed y prime equals, and I'm going to move this and this to, no, cannot, that's out here, 3x squared, sorry, that right there was attached with multiplication, but I can move this 6x y cubed to the other side, it becomes negative. Then I factor out a y prime. So when I factor out a y prime, basically y prime comes out of this one, and then I divide through. So negative 6xy cubed over, let's go with 9x squared y squared plus 4y cubed. Okay, so now, coming back up here, let's check this. If I go and put 6xy plus 4y plus 9x squared times this, I will have, let's see, we also see that you can, since every one of these terms has a, in this expression, every one of these terms has at least a y squared. So I can get rid of that y cubed, get rid of that y cubed, and get rid of this y squared completely. And so I'm really multiplying by negative 6xy over 9x squared plus 4y, and then equals 0. I'm wondering if this is true, and you see that these two cancel, and what you're left with is 6xy minus 6xy equals 0, and that is true. So it is a solution to that differential equation right here. So we're good to go. Let's do one more of these. And that's going to be it for this section. Number 38. So we have negative y squared dx, seems innocent enough, plus x squared plus xy dy equals 0. And then the integrating factor they want us to use is u of xy, or mu of xy, however you want to say that, but is 1 over x squared y. All right, let's just check. If we did it right now without the integrating factor, the partial of, this is m right here, so partial of that with respect to y would be negative 2y. If that's n, the partial with respect to x is just going to give us 2x plus y, so that doesn't work. So let's multiply through by the integrating factor. So we're basically dividing by x squared y on each term. Okay, and now let's just clean this up. This is negative y over x squared, because we get one of these y's to cancel, dx, and then plus, and then on this next one, notice that both of these terms have x, so I can pull an x out and that'll cancel one x on the bottom. So I'll have x plus y on top. I cancel one of the x's on the bottom, so I have xy on the bottom, dy equals 0. Now, let's check to see what the, if this is our new m and this is our new n right here, let's see what the partial of m with respect to y is. Well, that's just negative 1 over x squared, because y is like, y is our variable, and we can look at this as negative 1 over x squared as being like our constant right there. Okay, so we've got that. Now the partial of n with respect to x, well, that's a little quotient rule. So derivative of the top with respect to x is 1 times the bottom, minus derivative of bottom with respect to x is just y times the top, x plus y, and then all over the bottom squared, x squared, y squared. And this is going to be xy minus yx minus y all over x squared, y squared. So we get, this cancels, so we'll have negative y over, oh, you know what, that was y. When I distributed here, that was y squared there. Right there. That's y squared. So we have negative y squared over x squared, y squared, and the y squareds cancel, and we get negative 1 over x squared. And it matches. So we can go through now, and we can say the partial of f with respect to x is the m. And remember, this was the m here. So this is negative y over x squared. And then we integrate that with respect to x. So remember, this is negative y times x to the negative 2. So when we integrate that with respect to x, we just get y x to the negative 1. So just verify that real quick. Yes, that works. Plus some function of y potentially. Now we differentiate with respect to y, and now x is the variable, x is the constant, so you just get x to the negative 1 plus g prime of y, and that must match with this here. Now, doesn't look like it does, but let's write what we've got. We need 1 over x plus g, plus, plus g prime of y to be equal to x plus y over xy. Now, let's go ahead and multiply through by xy. So if we multiply this first term times multiply it times xy, the x's cancel, you just get y, plus xy g prime y equals x plus y. Now let's subtract y from both sides, which gives us that. And then let's, at this point, divide by x. So divide by x and we get that. And then let's divide by y. So g prime of y must be 1 over y. And that means g of y must equal the natural log of y plus some constant that we don't care about, right? And then I'll be right there. That means that our f function right here should be y over x, and then plus g of y, which we found to be natural log of y. And then let's just go ahead and do what we did before and say that must equal some constant. Now, I'm not going to check this solution. You could check it yourself that that does indeed satisfy the original differential equation.